Hello friends. So today we are going to create a doubly linked list with Python. So this is my code for doubly linked lists, and again we are going to make prepend, append, add after, add before, and remove methods. Also we can make a method as find and traverse. As you all know that a doubly linked list is a data structure in which each node contains a reference point to the next node as well as to the previous node, whereas singly linked list contains a reference of only the next node. Okay, so we have to take care of both of these references. Okay, so let's create a new file. Doubly list. Okay, implementing a doubly linked list. So class node. Oh, class node. We have to initialize, and it's gonna take data as its argument. Now self dot data equals to data. Self dot next is equal to none. So this next variable is a reference towards the next node, and we have to add self dot previous, initially set to none. Okay, we are done with the class now. Now class doubly, and again init, and now we have to make self dot double underscore head node equals to none, initially set to none. Self dot tail node equals to none. Self dot size equals to 0, initially it's going to be 0. And this head node, as you all know, head node is the first node and tail node is the last node. Okay, so let's make our first method, and it's going to be prepend, and it's gonna prepend a new data. Now we just have to make new node equals to node. New node is going to be an object of the node class, and data is passed in this object. Okay, instantiation. Now first we have to check that if the list is empty. So if self dot size equals to none and not self dot tail. You can use only the size variable, but I like to be more specific, so I'm using these not head and not tail variables to in my if statement. Okay, so when there is no item in our list, we are going to create the head node and the tail node. So self dot head will point towards the new node, and self dot tail is also going to point towards the new node. Okay, and now the else part, it means when there is at least one node. So when there is at least one node, we have to prepend, right? So while manipulating any node or adding a new node or deleting a new node in a doubly linked list, we have to rearrange the next and previous references really carefully. Okay, so now what I'm gonna do is we are prepending, right? That means we are adding a new data or new node um, before the first node or the head node of our data structure, which is linked list. Okay, so new node dot next equals to self dot head. Okay, so new node dot next is pointing towards self dot head. Self dot head dot previous points towards new node, and self dot head will now be new node. Oh, sorry, new node. It means new node is our new head node. I think I am clear to you all. And now finally we have to increment the size variable by 1. Okay. Similarly, we are going to make the append method, and it's gonna append a new data. We are going to copy this from line 18 to line 23 because it's going to be the same. Now we have to append a new data or new node. So we have to it means that we have to add a new node after the tail node. So self dot tail dot next equals to new node, and new node dot prev is going to point towards self dot tail, and self dot tail will now refer towards the new node. So self dot tail is now pointing towards new node. It means new node is our new tail node. Okay, I hope I'm clear to you all. Similarly, self dot size is going to be incremented by 1. So this size of variable is always taken care of, and it is this variable which is going to tell us that how many nodes currently there are in our data structure. Now we have to check these two methods. We are going to check all our methods like the moment we make them. Okay, so we are going to make two more methods, traverse. Oh, sorry. Traverse. So in the case of singly linked list, we created one method called as traverse method, and this traverse method actually displays all the data in our linked list. But singly linked list is one directional list. That means we can only traverse in a one direction. Okay, but in case of doubly linked list, we can travel forward as well as backward because we have this new reference called known as prev nodes. Okay, so I'm going to add fw, which means forward. So current node is going to be self dot head, and while current node I'm going to make it clear. It means while the current node is not null. Okay, So print current node dot data, and current node is now updated and it's going to be current dot next. Okay, so this loop will terminate when the current node becomes a none variable. Okay, so now we are done with our forward traversing. Now let's create traverse PW, which means backward traversing. Current node is going to be self dot tail this time, while current node print current node dot data, and this time current node is updated to prev. So we are traversing in backward direction, right? So let's check these two methods. If name my list equals to doubly, oh sorry, we have instantiated our class doubly, and my list dot append one, we are going to append one, my list dot append 2, my list dot append 3. We have appended 1, 2 and 3. Okay, now my list dot traverse forward, my list dot traverse backward, print statement, just to make it look different, we don't want our output to just get mixed up with each other. And now finally print size is going to be my list dot oh sorry, we forgot to make another method, and the method will be define list size. Okay, it's going to return a value self dot size. Now we're done. List size. Okay, let's see if it's working fine. Yes, so you can see that 1 2 3 this is forward traversing, and 3 2 1 is backward traversing, and we have 3 nodes. Okay, the size is currently 3 nodes. Let's prepend of some more data. This time we are going to prepend it. Okay, so my list dot prepend, let's prepend a 0, my list dot prepend -1, and my list dot prepend a -2. Let's see if it works. Oh yes, it is working fine, and we now have 0, -1 and -2 prepended in our list, and we can see the backward traverse also. So our first node is -2 and the last node is 3, and current size is 6. Okay, so these are our two basic append and prepend, traverse forward, traverse backward methods. Okay, so I'm ending this video here only, and we are going to discuss more methods in our doubly linked list in further videos. So see you there.